Ready? Hi everyone, I'm Kareem. Thanks again for hosting. Our project is SIA GPT, or Backwards Architectural Intelligence System, Project Control F. So what is SIA? I think most of us have worked with some format of a norm. They're pretty tedious to work with. They require a lot of background knowledge, and they're usually quite dense. PDF format, not necessarily machine readable out of the box. And so here's kind of our problem statement. It's difficult and time consuming, as I just mentioned. There's a lot of extra time spent on QCing and QAing for data correctness because, yeah, making a mistake is has a lot of implications. As we saw in the demonstration yesterday, existing LLMs don't provide totally accurate results, or maybe they're too general. And maybe some sub-problems. Versions change, often every year. And as we said, mistakes are not acceptable. And so here are kind of our requirements. We want this to be for humans who want to use these documents, and therefore response time should ideally be less than 10 seconds, maybe even less than 5 seconds. We do not want any hallucinations. We don't want it to make up any data. We want it to ideally link to where it found certain sources. So if you ask a specific question, it should find where it is. And of course, maximum accuracy. And so the solution is an AI assistant using RAG. And so here's a quick live demo. Do you mind helping me out here? Sure. It's just right there. So similar to one of the other groups, we decided to use kind of the chat format. It's a paradigm that we're all very familiar with. And so you can see, essentially what you can do is you can load a bunch of data in. So we've preloaded a lot of these SIA documents, as you can see here. You can also load additional data if you'd like. And then once you do that, we have some questions that we kind of, just so that you don't have to watch us typing, that we can kind of copy paste and just sort of demonstrate the functionality of it. And yeah, it's quite interesting sometimes what comes out. Let's have a look. Let's see if it does it in time. So the nice thing about this is if we can kind of scroll down to the actual PDF, we inserted an iframe so that it actually shows the PDF of where you find that information. It says page 21. If you just scroll down a little bit, the answer is actually right here, that you can't really see here, unfortunately. It's right there. So missed it by just a bit, and we can talk a little bit about why that is. Something to do with chunking and kind of how you arrange that data. If you could go back to the presentation, please. Mm-hmm. Right there. Sweet. All right, let's continue. Obviously, we had a video just in case everything exploded. All right, data ingestion. So for now, we just stuck to PDFs. We had to kind of organize them in certain ways, chunk them in certain, let's say, sizes, convert them into vectors using embeddings, OpenAI's embeddings models, and then store them in a vector database. From that, we basically ask it questions. The prompts are able to retrieve from the vector store. We use the LLM to take those results, and then hopefully it gives us an answer with some kind of relevance score. So I don't know if you noticed before, but it would say relevance of like 0.85. So it gives you a little bit of a sense of how well it's doing. The workflow or tech stack, all in Python. We used PyPDF, some of the embedding models from OpenAI. We experimented with a few. We used LangChain, which has really a lot of awesome open sort of out-of-the-box tools that for, let's say, a non-AI engineer was really helpful to use. Obviously, we used OpenAI's API, and then we hosted it on Streamlit, Dockerized it, and then we have a little bonus where we kind of looked at what's next, potentially. And so I think what we've also observed as a team is that a lot of these tables are linked, and they're really linked in quite a deep way, and so mentally you have to traverse them and find out which table reference what. And so wouldn't it be nice if the next step would be to use these language models to create kind of a network graph? Allows you to sort of follow, not only answer a question, but follow where is the sort of, where's the path to the actual answer? Maybe unit tests. Could you potentially ask a BIM model, hey, are these doors SIA compliant? It would say yes or no. Could be kind of interesting with some kind of confidence rate. Here's also a small demo that we put together where we just embedded it into Rhino. And so, again, potentially host it as an API, put it into some other environment, link it to some of the geometry data, and kind of see how we can use this in multiple environments. So kind of the conclusion or suggestions, write it in Markdown. That would make everything a lot easier. I think this is just a good demonstration of sort of what we were dealing with and what we struggled with. We had to kind of use these very sort of opaque chunking mechanisms. And so as you can see here, we printed out like the results of the chunks. And so essentially we had to get the language model to figure out our meaning or our intentions behind a question with that kind of result. So next steps would be obviously to study and research more about how we can potentially use agents and how we can honestly make the ingest a little bit more clear, a little bit more structured, maybe with Markdown. And I think we all are pretty confident that we can get like pretty good results if the ingest is quite clear. And that's it. You can give it a try.